quite literally, because in this video I'm going to be doing another exam, another high school exam, but this isn't just any old high school exam. This is one that I myself sat back in high school, and in this video we are going to see if I can still pass my old high school exam. Now, the exam you're about to see me do, I did indeed pass, and if I'm being perfectly honest, I did indeed get an A, but the hope is, having been, gosh, nearly 7 years since I took this exam, can I still pass it? And if so, can I also get an A? And you'd hope so, considering I've now done an entire degree in maths, but who knows, we'll find out in tonight's video, and I hope you all do enjoy me doing this maths exam while you all fall asleep. Maybe you can find it nice and relaxing, as well as at the same time maybe a little bit informative. And in which case, if you guys do want to try this exam yourself, I'll pop a link in the description to the paper. Feel free to give it a go, compare your results to me, and I hope you all do enjoy. So let's get into the exam. Okay, so here we are. I hope you all like this little setup that I have going on with my face cam. Also, the exam paper will be below us, and then over to the side there is where I will be writing all my answers on this little pad I have with a pen. It's not my iPad tonight, but before we get started, let's actually go over the paper. So this paper, for those wondering, well, I am from Scotland, so this is the official Scottish Qualifications Authority, they are known as, that sort of organise the exams for high school. Now this paper is known as the Higher Mathematics paper, and in tonight's video I think I'll just do the non-calculator paper. You do two papers usually, one non-calculator and one calculator, but if you guys want to see me do the calculator version as well, let me know in the comments. But this paper I did back in 2017, so it's been 6 years, almost 7, and I did in May apparently, quite early in the morning, and is worth 60 marks. You may not use a calculator. Okay, well, let's get started. We do get a little formula sheet that is quite generously provided by the examiners, such as the equation of a circle, scalar products, the trigonometric formulae and identities, well, some identities anyways, a table of standard derivatives and integrals, but yada yada yada. We're just here to get started with question number 1. I don't know if I need to zoom in anymore. I think I'll leave it just like this. Question number 1. I hope you guys can see this, because we are just going to get started with 1A. This is quite weird writing on this instead of my iPad. I think I'll put it down just a little bit more. There we go. So 1A, we have functions f and g are defined, I hope you can see my mouse, defined on a suitable or unsuitable domains by f of x is equal to 5x and g of x is equal to 2 cos x. Evaluate f of g of x. Okay, so a bit of composition here. We're going to start with the first one. So we want to evaluate f of g of x. Now f of g of x is just equal to the function f, except instead of x we have g of x, which is 2 cos x. So basically, for those wondering, anywhere you see an x you want to put in 2 cos x. So, oh sorry, no, but it's g of 0. So actually, let's redo this. So we have f of g of 0. So first, let's actually work out what g of 0 is. So g of 0 is equal to, anywhere you see an x and g, you just put a 0, so it's 2 cos of 0. Now cos of 0, if you think of the cos graph, is just going to be 1. So this is just 2. So therefore this here is equal to, so f of 2 is equal to 5 times 2, which is equal to 10. So that right there is going to be, I know all about this, I don't know why it's showing me. That right there is going to be our final answer of 10. Okay, so going back here, onto question 1b. We want to find an expression for g of f of x. So now we're doing the composite function but the other way around. So g of f of x, and we're working out a new function which we could give, hx, but we'll just call it g of f of x. And that is simply going to be the function g of 5x. So anywhere we see an x, we want to put in 5x in g. So that's going to be 2 cos 5x, and they've not put brackets around it, so I will indeed just leave it like so as my final answer. Whoops, still getting used to some of these new features here. So that is question number 1. Okay, so moving on to question number 2. Let's take a look at what we have here. So we have the point B minus 2, 1 lies on the circle x squared plus y squared minus 8x minus 6y minus 15 is equal to 0. So we have the equation of the circle and a point that lies on the circumference. Okay, all good. Find the equation of the tangent to the circle at point B. Okay, I think the best thing for us to do here is to draw a diagram. So let's actually start. We have question number 2. Firstly, so we'll write out the equation. We have x squared plus y squared minus 8x minus 6y minus 15 equals 0. Now immediately I can see from this we can work out the center of the circle using a little circles trick. And the trick is, because we have the coefficient of 1 in front of our x and y squared, we know that the center of the circle is, if we take these numbers here, 8 and 6, all we have to do is half them. So our center is going to be 4 and 3. And then we get rid of the negatives. So we have the center of our circle. So let's try and draw a little diagram. Now, I don't know if I can do a straight line. Can I? Oh, I can. How do I rotate it though? I don't know if I can. Can I? Okay, it seems like I can only put that at a 45 degree angle. I don't know. So we'll have to do this freehand, but let's draw our little axis. You know what? That's not bad actually. That is bad though. Anyways, we have a center at 4, 3. So let's just plonk that like there. Obviously, this is not to scale. We have 4, 3, and then we also have a point that lies at about 2, 1. So I'm just gonna, that's not 2, 1 at all really, is it? It's kind of more like there. Sorry, minus 2, 1. I said 2, 1, I think. So we're gonna have this circle that kind of goes around like, that was good until I got to that point. Like this. Imagine that's a better circle. And we want to work out a tangent to, or the tangent to the circle at the point B, so some sort of tangent, well, the tangent that goes down like this. Now what can we do? Well, we can actually draw the perpendicular line to that tangent, and notice that the perpendicular line to that tangent is the radius, which just so happens to go from point P to the center C. So that's quite nice. If we can work out the equation of that gradient, we can therefore work out the gradient of the tangent using the rule of tangents. So let's go back to our black pen here, and we'll call the gradient of the radius m of r. Should really be lowercase r, but ignore that, and we'll just do 3 minus 1 divided by 4 minus 2, which is plus 6. This is just the gradient formula, and that's going to give us 2. Wait, why did I put 6? I meant to put 2. It's because I said I was too busy thinking that it's going to give us 6. So that's going to give us 2/6, which is 1/3. And therefore the gradient of the tangent, which is usually given that the perpendicular tangent, or the line perpendicular to that, is going to be minus the inverse of that, because you divide it by -1 and all that stuff. So we are going to have -3. So I think you do -1 divided by 1/3, and that's going to be -1 multiplied by 3/1, which is just -3. So that's technically how you get that, in case people are wondering in the comments. So we have the gradient of that line there, and we also have a point on the line. So therefore we can use the formula y subtract b is equal to mx subtract a, which is a formula used for working out equations of lines when you have a point AB and you have a gradient m. So our gradient is -3 and our point AB is simply -2, 1. So let's put b -2, 1 is a and b, and then we'll just fill this out. We have y subtract 1 is equal to -3x plus 2. So then we're going to have y subtract 1 is equal to -3x minus 6, and then we want to take the 1 over, so we're going to get y is equal to -3x, not plus, -5, and that is the equation of the tangent to the circle at the point P. A lot of working there, but not a bad question. Okay, question number 3. Let's see, what do we have here? A bit of differentiation. So, given y, let's start this out. So question 3, given y is equal to 4x minus 1 to the power of 12, find dy by dx, find the derivative of y with respect to x. So here we're going to be doing some differentiation, nice and easy, just using a little rule known as the chain rule. So to do the chain rule, we want to bring the power down to the front. We want to keep the bracket the same, and then we want to subtract 1 from the power. But the little step in between, you want to multiply by the derivative of the bracket, which in our case is the derivative of 4x minus 1, which is just 4. Now we could leave it like that, but we can make things a little bit nicer. We can multiply out the 4 and the 12 and get 48, and just write 4x minus 1 to the power 11. And that is question 3. Quite nice, actually. Not too bad. So moving on to question 4, we have, hope you guys can see this, find the value of k for which the equation x squared plus 4x plus k minus 5 is equal to 0 has equal roots. Okay, now if I remember correctly, using the quadratic equation, if it has equal roots, the discriminant must be equal to 0, because you need the version where you use the plus to be equal to the version where you use the negative, so therefore it must be equal to 0, so you get square root of 0, which is 0. So therefore we will say if equal, the discriminant, which is b squared minus 4ac, must be equal to 0. So what are the values b squared, a and c? Well, let's take our thing here. We have x squared plus 4x plus k minus 5 is equal to 0, which is perfect. So we have three coefficients. We have a secret 1 in front of the x. We have a 4 in front of, the x squared. We have a 4 in front of the x. And in front of the x to the power 0, technically, we have the constant, which is k minus 5. So we want to work out what k is going to give us in that instance. So here we have a is equal to 1, b is equal to 4, and c is equal to k minus 5. If you were to write this in the form, let's do this to the side. If you were to write this in the form ax squared plus bx plus c equals 0, that is what you'd get for a, b, and c. So therefore, when we put this into this, b squared minus 4ac is going to be 4 squared minus 4 times a, which is 1, times k minus 5, and we need it to be equal to 0. So 4 squared is 16 minus 4ac. 4 times 1 is 4 times k minus 5. We have 4k, and then 4 times minus 5 is minus 20 is equal to 0. 16 minus 4k plus 20 is equal to 0. 16 plus 20 is just 36. So we have 4k is equal to 36, or k is equal to 9. And that is going to be our answer for if this has, equal, did I say no real roots? I don't remember, but if it has equal roots, then yeah, that's what we're going to get. I don't know why I did it like that. There we go, I'm still getting better. I think we're doing okay in this so far. So let's move on to the next question. Okay, question 5. Let's scroll down a little bit. Let's get some room here. So, vectors u and v are 5, 1, minus 1, and 3, minus 8, 6 respectively. Part A says to work out the scalar product u dot v. The dot at the end kind of makes that a little bit hard to read, but anyways, so if I remember correctly, on the formula sheet they give us the scalar product. Now I do remember how to do it anyways, but for those wondering, we'll write it out. So we have, whoops, still got this up. We have, what am I doing? We have for 5a, u dot v, and usually we put like a line underneath if we can't make it bold, is going to equal u1 v1 plus u2 v2 plus u3 v3. Then, therefore, 1, 2, and 3 are just the first, second, and third elements of the vector. So we have 5 times 3 plus 1 times minus 8. And to make this easier to read, I'll put them in brackets for you all. Plus, and then we have minus 1 times 6. Okay, so therefore we evaluate these. We get 15 plus minus 8 plus minus 6. And of course the negatives, we'll just get rid of the plus. So we're going to have 15 minus 8 minus 6, which is 1. So that is the scalar product of u, v. Part B, what do we have? So we have a diagram of u and v, or u and w now, sorry. Vector v makes an angle of pi over 3 or 60 degrees, with u and w, the magnitude of w is root 3. Calculate u, w, the scalar product. So again, we have another version of the scalar product here, where, and I'll write this down because sometimes I do forget this, we have, in our case, it was u and w, I think. So u dot w is equal to the magnitude of u times the magnitude of w times cos and then an angle. So let's get those values from our question. So the magnitude of u, let's work that out, the magnitude of u. So the magnitude is the square root of all the elements squared. So 5 squared plus minus 1 squared, which is just 1 obviously, and 1. Now I've done them in the wrong order, but it won't make a difference. So that's going to give us 5 squared is 25. Ooh, why did I do 2 to the power 5? 25 plus 1 square root. And that is equal to square root of 27, which we can simplify to, we have 9 times 3, so 3 root 3. Okay, and then we have the magnitude of w, which is square root of 3 as well. So we can already see that's going to kind of cancel out later on. And then therefore we need to work out cos of the angle, which is in between. Do they actually describe it in this? Yes, where theta is the angle between A and B, so the angle between u and w is pi over 3. So we want to work out cos of pi over 3. Now luckily for this, we can use our exact values triangle, which I actually did a video on trigonometry, and in the video I talked about this here, where if you have a triangle with pi over 3, which is technically 60 degrees, and then you have 30 degrees, which is pi over 6, obviously that makes 180, you will have values 1 and 2. This here will give you root 3 using Pythagoras theorem. So given this, we can work out cos of pi over 3. So cos is adjacent over hypotenuse, which is 1 over root 3. 1 over root 3, which is going to give us, it's 1 over root 3, no sorry, I've done that in the wrong way around, that's why. This is 1 root 3, I want to do this in blue, where's my blue? 2 root 3, that's more like it. Therefore, now we are going to have the cos of that. Now we get a half, which is what I was expecting. I was visualizing the curve in my head. So now we can put all that together and we're going to get that u dot w is equal to 3 root 3 times root 3 times a half. Now root 3 times root 3 is 3, so we're going to have 3 times a half, which is 9 times a half, which is 9 over 2, or 4.5 if you like. And that is going to be our answer for question 5b. Alrighty, moving on. Let's scroll down, give ourselves some more room. Go back to our black pen here. And let's see what we're working with. Question number 6. A function h is defined. H of x is equal to x cubed plus 7, where x is defined on the real. Determine an expression for the inverse function of h with x. So what we have here is a function h of x is equal to x cubed plus 7. Now the way I was taught to work out an inverse function is you simply want to replace it with something like y is equal to x cubed plus 7, and you want to rearrange for x, and then at the very end you change the y's to x. So I know that sounds really counterintuitive, but essentially we're just doing a little bit of rearranging the equation, or changing the subject. So we want to change the subject to x. So we start by doing the opposite of BIDMAS. So we subtract any numbers. So we're going to subtract 7. And then to get x on its own, we just do the cube root. So x is equal to the cube root of y minus 7. And the very last step, I just say so. We put the inverse function is equal to, and then you replace all y's with x. There's probably a better way of explaining that, but that's kind of the way I was taught, and it's not so bad. Okay, question 7. Let's see, what do we have here? There we go. A, B, and C, which are those points there, you guys can take a little look at them, are vertices of a triangle. Okay, find the equation of the median through C. So the median is the point. So it's a line that goes through the middle of or a line that basically cuts through the middle of C. So if we draw this triangle out to the side, we're gonna have I won't bother doing an axis this time. Let's just draw what we think is minus 3, 5. Then we're gonna have 7, 9, like up here or something like that. And then we're gonna have like 2, 11 all the way up here. I know this is not good at all, but we're gonna have a triangle that goes something like that, and I will put the points just to make it a little bit easier. So we have A minus 3, what am I doing? Minus 3, 5, B is 7, 9. That's actually not a bad diagram. And C is 2, 11. So we want to work out the median, which is a line that passes through this point here, that cuts this line C Oh no, sorry, the median through C. Oh, so it goes through the point C and this line here. So this line here is what we're wanting to work out, basically. Yeah, so it goes through C and cuts the line opposite it in half. That's what I meant to say. So we have a point 211. If we can work out this point here, we can simply work out the equation of the line. So let's work out this coordinate of the middle. Well, we are just going to use the median formula, which is, let's call this point D, just for making things easier to read. So the point D, if we use the midpoint formula, is the midpoint of A and B, which is equal to the x coordinates, so x1 plus x2 divided by 2, and then the y coordinates, y1 plus y2 divided by 2. So therefore D is the point -3 plus 7 divided by 2 and 5 plus 9 divided by 2. Okay, sorry, I'm like so focused. I don't want to get anything wrong. I'm sure I will make a mistake because it's very late and you guys will all let me know in the comments. So -3 plus 7 is 4 divided by 2 is 2. 5 plus 9 is 14 divided by 2 is 7. So D is the point 2, 7. So we now have 2 points on the line through the median, and I've actually realized I have drawn this not very good, because notice that C and D have the same x coordinate, which is 2. So I'll put and C is 211. Now I've noticed that. Luckily I didn't continue doing much more working because we can skip a few steps here actually. Since they have the same coordinate, we can say since D's x coordinate, I don't know, I'll just do dx, and C's x coordinate, that's probably not notation at all, but are both equal to 2. We'll say the median through C is x is equal to 2. This should be a straight line like this. Oh, what have I done? I don't know what I've done, but that's my desktop. Oops, there we go, it's loaded back up here. This should be a straight line, basically. So, my diagram wasn't amazing, but there we go. That is the end of question number 7. Okay, so I fixed up this a little bit because I think it slightly zoomed out when it crashed, so I've zoomed in again for us to make it easier, and I think everything looks good checking on my other monitor. So let's move on to question 8. I do apologize again. So we have calculate the rate of change of the function dt, which equals a half or 1 over 2t, where t does not equal 0, of course, when t is equal to 5. Okay, so this little fancy term here, rate of change, simply just means the derivative. So we have a function d of t which equals 1 over 2t, which we can also write as 1 over 2t to the minus 1. Now the reason I've changed it like this and given it a negative power is to make it easier to find the derivative. Because now when we find the derivative, we bring the power down to the front, multiply by any coefficients. So we get negative a half t, and then subtract 1 from the power, we get minus 2. Now I could keep it like this, but again I'll change it back. And we're going to get negative 1 over 2d squared. So at t is equal to 5, we are going to have d, the derivative of d of 5. Now sometimes you could write t equals 5. In this case I just have 5. Doesn't really matter. We're going to have minus 1 over 2 times 5 squared. Now 5 squared, whoops, is 25 times 2 is 50, so we are going to just have minus 1 over 50. And that is question 8. So we're on question number 9 now, I think. Okay, we have quite a few funny questions going on. I think question 15 is the last one, so we're making good progress here. I don't know if I've made many mistakes, which is good. But did I say question 8? I meant question 9. We're on question number 9. So 9A. We have, a bit of sequences. I don't know if I remember too much about my sequences and series, if I'm being honest with you, from high school. Gosh, okay, so a sequence is generated by the recurrence relation un plus 1. So the next term is equal to m times un, so the previous term, plus 6, where m is a constant. Given that u1 is equal to 28 and u2 is equal to 13, calculate or find the value of m. Okay, so that's actually not so bad. That's just a bit of algebra, basically. So if we let n plus 1 is equal to 2, then n is equal to 1. So we have here that this 2 is referring to the 2 in u2, and this 1 is referring to the 1 in u1. So that's just me sort of keeping that in my head. So therefore, I'll put like a little fancy therefore symbol. We'll have u2 is equal to m times u1 plus 6. So what this basically says is each next term is multiplied by this value m from the previous term plus 6. Now u2 is 13, so 13 is equal to 28 m plus 6. So it looks like we're probably going to get a negative value, I think. So let's take a look, because it's decreasing each time. So let's take away 6. We're going to get 7 is equal to 28m. So we're going to get, oh no, we're not going to get a negative term, we're just going to get a factoring term, which is going to give us m is equal to a quarter, because we get 7 over 28, which is a quarter, so that's why it's getting less and less and less. Okay, nice. And we can actually check that. So let's check. Let's suppose we have u1, which is 28. We have 28 times a quarter plus 6 times a quarter divided by 4 is 7 plus 6, which gives us 13. So we know that that is correct. Okay, nice. That's what I like about sequences and series and recurrence relations, is you can check them all. So part B has 2 parts to it. First up is I, which is about limits. Okay, this I know a little bit about, so explain why this sequence approaches a limit as n approaches infinity. So it will approach a limit, if you think about it, because the value of m is between negative and 1. It will therefore eventually get to a value that will just continually remain at that value when n goes to infinity. So we will say there exists a limit as m, which equals a quarter, is between -1 and 1. If it was greater or equal to them, it would not reach a limit. And I'm assuming part I will want us to work out that limit. Yes, calculate the limit. So we want to calculate the limit. Let's call it L. So to calculate the limit, we want to work out the value at which it stops at. So the limit L is going to equal a quarter L, because when it gets to the end, it's just going to keep giving the same, plus 6. So therefore now we can just work out these values. So what we want to do is we want to what do we want to do here? We want to, because I think if you take that away, you're going to get 3 quarters L is equal to 6. So L is going to equal 6 multiplied by 4 over 3. Yes, that seems reasonable, I think. Which is 24 divided by 3, which is equal to 8. Okay, I don't know if it's right, but we can test it again by assuming that L is the maximum term. So we can try it with M. So we'll have 8 is equal to 8 times a quarter plus 6. So let's find out, is that true? 8 times a quarter is 2 plus 6, which is perfect. So there we go, that is the limit. I know that's a bit complex to explain, but I hope that makes sense. And yeah, let's move on to the next question. So on to question 10 now, which seems to be a bit of a funky question here, but has a bit of integration involved. So let's get cracking with this. So for 10a, we have two curves with equations y is equal to x cubed minus 4x squared plus 3x plus 1 and y is equal to x squared minus 3x plus 1 intersect as shown in the diagram. Okay, so they intersect at the points where x is 0 and x is 2. And we are asked to calculate the shaded area, which is the area between two curves. Now, like I said, when you have the area between two curves, you just want to do a bit of integrating, really. So we have that it's going to be the integral between the x coordinates that they meet at, which is 0 and 2. And it's from the difference of the two curves. So because they both equal y, we can say that it's going to be the upper curve subtract the lower with respect to x. Now let's work out what upper subtract lower means. So what this means is we have the upper curve, which is x cubed minus 4x squared plus 3x plus 1 subtract the whole bottom curve, which is x squared minus 3x plus 1. And the reason we do this is because y is equal to the same in both cases. So you're basically setting them equal to each other. So this is going to give us x cubed and then minus 4x squared minus x squared is minus 5x squared. 3x minus 3x, well that'll just drop. Oh sorry, I'm forgetting it's minus, so it's plus. So we're actually doing 3x plus 3x, my bad, plus 6x. I would nearly have made a mistake there. I mean, I maybe have made one already, but the end term is going to just drop because that's going to be plus 1 minus 1. So therefore, we are working out the integral between 0 and 2 of x cubed minus 5x squared plus 6x dx. Okay, let's evaluate this definite integral. So when we integrate this, we increase the power by 1 and divide by the new power. So we're going to have a quarter x to the 4 minus 5. I can't believe they're making this non-calculator. I guess one will probably give 0. Anyways, minus 5 over 3x cubed plus, and then 6. It's going to go x squared divided by 2. 6 over 2 is just 3, so 3x squared. Much easier with a calculator, but a bit of a nasty question. We can evaluate it. We only really need to evaluate it for 2 because we can see when we input 0, it's just going to give us subtract 0. So substituting in 2, we're going to get a quarter 2 to the power 4 minus 5 over 3 times 2 to the power of 3 plus 3 2 squared, and I'm just going to put subtract 0. We're just going to assume it. So evaluating this now, 2 to the power of 4 is 16. So 16 times a quarter is 4. And then 2 to the power of 3 is 8. 8 times minus 5 minus 40 over 3. Gosh. And then 2 squared is 4 times 3 is 12. So plus 12. Now let's get this as one whole fraction, so we'll make everything a fraction of 3. So we have 40 in the middle. 4 as a fraction of 3 is going to be 12, and then 12 as a fraction of 3 is going to be 36. So therefore we have 12 minus 40, which is negative 28 plus 36 is 8 over 3, and that is going to be in units squared. So that is part A. Gosh, that wasn't nice at all, was it? And part B doesn't look that much greater. Let's take a look at part B. Part B says the line passing through the points of intersection of the curves has equation y is equal to 1 minus x. Determine the fraction of the shaded area which lies below the line. Okay, so we have the area as a whole. If we work out the area below the curve, we can therefore work it out as a fraction. So now we do the same again, basically, but with different curves. So we're doing it between 0 and 2 again, and we have upper minus lower dx, and this time our upper minus lower, well, we know our lower is going to be the bottom curve, so our upper is just going to be 1 minus x subtract and then the bottom curve, which is a little bit of a simpler curve than the very upper curve. And so now we're working out this kind of area that goes like this, basically. We're working out that area in here. So we are going to have between 0 and 2 of, let's do negative x squared, and then we're going to have negative x plus 3x. So we're going to have plus 2x, making sure I don't make any mistakes here. And then 1 minus 1 is going to go away, so that's actually really nice and simple. So we're going to get the definite integral of minus 1/3 x cubed plus, and then 2 divided by 2 will come to just 1, so we'll have x squared. And between 0 and 2, and again we're going to assume that the 0, when it's substituted, will give us 0. You guys can kind of just notice that. So that's going to give us negative a third of 2 cubed plus 2 squared minus 0, which is going to give us 8 minus 8 over 3, which is almost very similar to what we got before. Probably a way of working that out. Plus 4. So again, let's do this as 2 fractions. So 4 we said was 12. So wrong bit. So we're gonna get 4 over 3, which is exactly half our answer in part A. So because it's exactly half, the fraction of the shaded area which lies below, we'll say the fraction of the area below the line is a half. Exactly. And there we go, that is part 10b complete. Okay, so for question number 11, we have A and B are the points, negative 7, 2, and 5a. AB is parallel to the line with equation 3y minus 2x is equal to 4. Determine the value of A. Okay, so this is quite sneaky. So we see the word parallel in there. We immediately think that 2 parallel lines, they'll never meet, sadly. So they will always have the same gradient. So if they have the same gradient, we know that the gradient of the line AB, which we know is from the point minus 7 to some point 5a. We don't know where a is, so we'll just put it here. The gradient is the same as another horizontal line. So it's going to equal oh, I see. So the gradient of AB is going to equal the gradient of that line. Okay, so actually, before we write that, let's work out the gradient of the parallel line. We'll write par. So, what we need to do is, I'm going to just get rid of that all, to be honest, because we have the equation 3y minus 2x is equal to 4. We need to work out the gradient using this, basically, so we're going to rearrange to write 3y is equal to 2x plus 4. Then divide everything by 3 to get y is equal to 2 over 3x plus 4 over 3. And that gives us our gradient. So the gradient of AB is equal to 2 over 3. There we go. But we want to work out A. So to work out the value of A, we can use the gradient formula. Now the gradient formula says that the y coordinate subtracted divided by the x coordinate subtracted, which is just, vertical over horizontal, is equal to the gradient. So we have y2 take y1 over x2 take x1 is equal to MAB, or in our case, we have A subtract 2 divided by 5 subtract negative 7 or plus 7, which is equal to 2 over 3. So now we just need to solve this. So we have A subtract 2 divided by 7 plus 5, which is 12, has got to equal 2/3. So how can we solve that? Well, let's multiply the left and the right side by 12. So we'll get a minus 2. And then if you multiply by 12, you're going to get 24 divided by 3, which is 8. And then you just want to add 2 to both sides to get 8 is equal to 10. And that is our answer for 11. So the next question number 12. Let's grab the pen. We have a little bit of logarithms. Gotta love some logarithms. So given that log to the base a subtract log to the base a of, we have 36 and 4 is equal to a half. Find the value of a. Okay, so firstly, using our laws of logs, we know that when you subtract logarithms, it's the same as, dividing them, the values that are after them. So this is going to give us log to the base a of 36 over 4 is equal to a half, and that's using the law of logs. So that gives us log to the base a of 9 is equal to a half. So how do we work out a for that? Well, if I remember what this means, it means what power do we raise a to get 9? So it's kind of like a to the power of a half is equal to 9. That's what this thing here means, basically. It means we raise a to this power to get that. So this value here is a to this power. So what this here means is the square root of a is equal to 9. And then if you just, square both sides, you'll get a is equal to 81. And I believe that's that. But I hope I'm right with that anyways. So, question number 13, okay. We have a bit of a tricky integration question in my opinion anyways. Let's take a look here. So we want to work out the integral of, that's not a good line at all, 1 divided by 5 minus 4x to the power of a half. Okay, now that's probably easier to integrate if we were to rewrite it as 5 minus 4x to the power of negative a half dx. So now that we've got that, we can integrate and make it a little bit easier. So we want to, when we integrate, we increase the power by 1 and we divide by the new power. But because in this instance we have this thing in the bracket, we need to remember to divide by the minus 4. So what we're going to do when we integrate this is we're going to have increasing the power dividing by, can I get a straight line please? Is that going to straighten it? I didn't realize that. Oh my goodness. It's taken me, like nearly an hour. So we're going to divide by a half, which is the new power. And on the top, we're going to have 5 minus 4x to the half. And then we need to remember to multiply by the minus 4. Why have I done it like that? By minus 4. So once we've got that, we can simplify this up a bit. We're going to have 5 minus 4x to the power of a half divided by minus 2, which I guess you could rewrite as negative a half square root 5 minus 4x. should be, oh, wait a minute. I'm forgetting plus c. There we go. Never forget your plus c's. I nearly did that there. If you do, I believe you drop a mark. So hopefully younger Dido remembered to add a c. So I think we're almost done here. Moving on to question 14, which we have is express root 3 sine x minus cos x in the form k sine x minus a, where k is greater than 0 and a is between 0 and 360 degrees. Okay, that's quite a tough question, but I think using a little bit of trigonometry and maybe simultaneous equations, we can maybe give it a go. So 14a, let's take a look here. So we have root 3, let's write it out, root 3 sine x minus cos x, and we want to write it in the form k sine x minus a. Well, if we take a look at what this over here will look like once expanded, we will have root 3 sine x minus cos x is going to give us k sine x cos alpha, or sorry, a, minus k cos x sine a. And that's just simple expanding there. Now, we can create two simultaneous equations by comparing this part here to this part here. When we compare it, we can see that the coefficient root 3 is going to equal the coefficient in front of the sine x here. So in front of the sine x here, we have k cos a. And then when we take a look at the coefficient in front of the cos x here, we have minus 1 is equal to... sorry, the coefficient is technically 1, my bad. Which is equal to k sine a. So now we have that. So what we want to do basically is work out what k and a both are. So let's start by working out a, which we can probably work out by dividing both equations. Because if we take k sine a divided by k cos a, we're actually going to get tan of a. Now tan of a is going to equal 1 over root 3 as we have on the left hand side. So if we actually go back up to our triangle we made ages ago, tan of 1 over root 3 is going to be pi over 6, because it's opposite over adjacent. So pi over 6, which is 30 degrees. So we'll say, therefore, a is equal, 30 degrees. We'll put pi over 6. Now we want to work out k next. So how can we work out k? Well, what we can do is square both terms, and we can have the k cos a squared and add them together, k sine a squared is equal to, well, it's going to simply equal to root 3 squared, which is 3, plus 1 squared, which is 1. And the reason we do this is because this thing on the left hand side is going to give us 1, which will leave us with just k, because you're technically going to have the sine a squared plus cos a squared, which is 1. So k squared when you do that there, it's going to give us 4, which gives us k is equal to 2. So now we've got k and we've got a. We can rewrite it as, therefore, it's equal to 2 sine, and then x minus 30 degrees. And there we go. That is part A. Now, I was just looking at part B and noticed that it says to use the diagram provided in the answer booklet, but basically it wants us to sketch the diagram for what we've expressed as 2 sine x minus 30. Now, I don't have a diagram, so I am going to get this diagram here, and I'm going to take a screenshot, and we're going to put it right here. Oh, beautiful. If I can write on that, that's even better. So let's take a look here. We want to graph 2 sine x minus 30. So what does this 2 and what does this minus 30 actually change to our usual sine wave, which, you know, is gonna you go up to 1 and come down like this. I mean, you get the idea. I can't really draw it very well, but I'm gonna have to, because it needs to go up to 2. What this 2 does is it stretches the amplitude, so it's gonna now go up to 2 at a peak. Now, the negative 30 simply shifts it to the right by 30. So instead of starting at 0, it's going to start at 30 and go up to 2. So let's actually, I have an idea. Let's grab a different color. Let's get blue and sketch our old sine wave, which is going to go through here and to a peak of here, and at 270 come down to -1 and go back through at minus or 360. So our old sine wave is gonna go like this. Oh, what is happening? Like this, there. And then if we can do this here, I don't know why my hand is so shaky that it's struggling to draw. There we go. That's not bad. Now we'll take our black pen, and we can see that everything's gonna move over. So we're gonna have a point here, plus 30, we're gonna have a point here, and we're technically gonna have another point that's 30 over at 390, but it should just line up for us nicely because we have a peak. We have a peak at 120 and 300, but actually it's gonna go up to 2, isn't it? We said. So it's gonna look a little bit better as it goes up to there and comes down to -2 at 300. So now our sine wave, which has shifted a little bit and stretched a little bit, is going to look something like this. And then it's actually going to go just beyond, like that, and then come just down a little bit. I mean, that's probably not so great, but something like that. And that is what our sine wave is going to look like. That should be enough to get us the marks. But again, it's a diagram's a diagram. It's never going to be amazing. So we have the final question here, which is question 15. So for the final question tonight, 15, start with part A. Now I have done a little read over this question already to see if we needed more diagrams, but it doesn't look like it. So we have a quadratic function f is defined on the real set of numbers, or the set of real numbers. Diagram 1 shows part of the graph with the equation y is equal to f of x. We can see the graph there where we have y is equal to f of x has the turning point 2, 3, and it crosses the x-axis at 1, 3. Diagram 2 shows part of the graph with equation y is equal to h of x. The turning point is 7, 6, so we have the turning point 7, 6. This is hx. And we have this little box inside, we'll get to that later. But it has the points 6 and 8. So we have given that hx is equal to f of x plus a plus b. Write down the values of a and b. So h of x is some version of f of x, basically. And this is kind of what we just did in the question before, I believe, where we're just doing a little bit of changing of a graph. So inside the bracket we said it's getting shifted to the right. So it's going to be negative. So a is going to be negative some sort of value. Now a used to be 1, now it's 6. So it's been shifted to the right by 5. So minus 5, nice and easy. Now for b, this is how much we've changed or stretched the curve by. So in this case it's stretched from 3 to 6. So b is going to be 3. Moving on to part b. It is known that the integral from 1 to 3 of f of x dx is 4. Okay, so actually what I'm going to do is similar to, similar to before. I'm going to grab this diagram and I'm going to put it here. Because what that is saying is that this area in here is equal to 4. And it wants us to determine the value of the value between 6 and 8. So basically in this little box in here of h of x and this bit here. Now this bit here is simply going to be the same as this bit here because it's just being shifted over. So we want to work out the extra area of this little box and add it onto that, which is 4. So we want to work out the integral from 6 to 8 of hx dx. Now this is simply just a square, a rectangle, which is 2 by, well, it started at 0 and it's up to 6, it went up 3 in this case. So that's from 3 to 6, which is 3. So therefore this is 3i by 2, which is going to equal 2 times 3, which is equal to 6. And so it's going to equal that plus 4, which is what from 1 to 3 was. So we're going to have 6 plus 4, which is equal to 10. And now on to the final question, the final part. Where's my pen? Given f dashed of minus 1 is equal to 6, state the value of h dash of 8. Okay, I think for this question, what do I think for this question? Well, okay, so I've got it, because that f dashed of 1 is equal to 6. What that is saying is that the gradient of the tangent to this curve, let's draw it. It's saying that the gradient of the tangent to this curve, like this, is equal to, what did it say, 6? Yeah. So what we know is that for the other side as well, at 3, it's going to be minus 6. Now that's an awful diagram, an awful drawing, I know. So it's going to actually be the same over here at the point of 8, because this is just going to be sort of the same thing here with that and that. So we're going to have -6. So all in all, the value of h -1, oh, sorry, not -1, h dashed of 8 is going to equal -6. Wow. And there we go. That is the end of the exam. I think I definitely would have been much better at doing it when I was younger. That there, a lot of it was taking a while to come back to me, but I think I've done okay. Let me know in the comments if you guys did enjoy this, watching me sit an exam that I have previously done, and hopefully, fingers crossed, I did okay. I did alright. Let me know if I have made any mistakes. Again, I apologize about a few bad diagrams and little mishaps throughout the video, but that is all 15 questions of the exam. Oh boy. And there we go, right back up to question 1. Don't ask why this says the 8th of August 2023. I don't know. But that is that. I really hope that you all did enjoy this video. If you did, why not consider leaving it a big thumbs up? It would really mean a lot to me. And yeah, let me know if you want to see me do the second paper, as there is a second part. But I will pop again the PDF to this paper in the description in case you're wanting to try it yourself. I think question 10 was definitely one of my favorites. The sequences question caught me off guard. It was quite good. I like the vectors one, the differentiation ones, and the circle one was quite interesting as well. I like the circle one. But I hope you guys did enjoy. Thank you so much for watching. Sleep well, everybody.